So now I just want you to show that an Hermitian matrix, or more an Hermitian preserving map, has an Hermitian Chern matrix. So Chern matrix is just this sum of EG of EG XOR EEG. And so it takes a dagger of it. Then it's equal to sum of EG GI. So EG dagger, but a Hermitian preserving map is just that this, and so just equal to sum of EG of GI XOR EGI. And so it just proves that it's the same. So it's an Hermitian Chern matrix, because if we call it A, then here A dagger equal A, so it's Hermitian by definition. So using the previous parts, shows that the Hermitian preserving map using A, it shows it's Hermitian preserving map can always be written as a diff of two completely positive map. So you need to know that an Hermitian matrix has always real value. So it means negative and positive. So it can always be diagonalizable. There's always a diagonalization. So if we call it C, it's equal to of the it can also be written with unitary matrices. So UD dagger. And so if you take like two matrices, like P represented the real value is equal to 0, and Q the real value is inferior to 0, it's equal to, can be equal to P d p dagger minus q d q dagger. This way you put a minus this way, minus q becomes superior to 0, and so this is superior to 0, and so we have that p and q superior to 0, and so c can be written as p minus q with p and q in positive definites, but we know that if a matrix of a map can be written as the diff of 2CP map, in the case of a linear map, then the map itself can be written as the diff of 2CP map. So epsilon of c equals epsilon of p minus epsilon of q with this and this being CP map.